Alright, so we all know how the Gen 1 and a few years after that Viragos sound when they start, with that clanky, rattly, noisy junk from where the Bendix gear kicks out and rattles back and forth. So I wanted to kind of see, is there something we can do just to make that starting system quiet? So I've gone through, you can see the other videos on the channel where I went through and machined the side cover and added a clip and shortened spring and did some of that, and all that works pretty good to keep it from grinding out, but they still just make a tremendous amount of noise when they start. So I got to looking, and for my cafe build here I still got the motor off, and I got a couple of extra heads and things laying around, so I thought, I wonder if you could put compression releases in these heads, and that would drop that compression down at start, and then when it starts it will close the compression release, and then we'd be able to have a lot quieter start. So got to looking on these heads, and there is not a lot of place to put a compression release. You definitely can't get over here by the spark plug because there's not enough room, and you can't get through the other side, and you can't get around in here because it's got cavities inside of it. But I did, looking around inside of it, see that maybe if I can drill a little pilot hole somewhere right around in here, then I might be able to go down with a hole and then come in from the side and take this screw out and then drill in and catch that hole, and then replace this with like an adapter or something. I can make it on my lathe and make an adapter that'll catch that screw, still hold that plate down, and come out, and then maybe I can get through the side of the cover right here with the compression release. So we get set up on that, and then we'll be back to drill some holes. Alright, so we got our head mounted down, not clamped down tight yet, but I want to check and see if sitting down on the top of where the bolts go through, if that was the surface that they used to mount the machine this head. And so I got me an indicator up, and I'm down on some 1, 2, 3 blocks on the bottom, and so if I crank across this head, you can see our little gauge is not moving at all. So that means using that as a reference is a pretty good position. So now all we got to do is square this thing up so I can try to hit that hole in an accurate way. Alright, so for this one we're going to come touch off on this surface. It's not a machine surface, but it's good enough. So let me get over here. You can see where we are on our gauge. For what we're doing, that is plenty good enough on square. So now we can lock everything down and get ready to machine this thing. Alright, so next we got to figure out where the zero of that surface is. So I got me a edge finder on here. So that should put the edge of my bit right on the edge of that, the center of the bit. Alright, so now let's change out for our drill bit, and then we're going to figure out the down position and then figure out the back. And so what I want to do is, let's lower the camera down so we can see in there. So what I'm looking to do is align the end of the drill bit there up with the center of that hole. So as long as I'm into the center, I'm all right. So right down in the side of there, we should have the drill bit. We got it visible. So now all we got to do is come over this way and just center that up. So I'm just going to eyeball that. All right, so that should be our location. So I'm going to lock this direction down just to remind me not to move. All right, so now all we got to do is go back in to zero again. And we should be back right on the edge of that. So now we're ready to scoot in this way and drill this hole. So the best I can figure, we need to come in about 1 inch to get into the solid metal that'll connect up to that hole right there. So now if we want to see if it made it in there or not, all we got to do is just fill it up with some WD-40 and we'll just show you that it made it. I'll just blow that back out of it. We'll put that in that hole and then you should see the WD-40 come out. So we hit it dead on center. Everything looks really good. So now all we got to do is just set up and do the other head, and then we'll flip it sideways and see about changing this screw out for a little bit bigger one so we can make a little adapter. All right, we'll be back once we get the head flipped over and set up. All right, so we are set up with the head in this orientation, and it turns out this is a bit of a bear when you're just setting it up. I'm going to make some blocks for all these shims and things I stuck in here, but you got to use feeler gauges and everything to try to get it level. Now over on the back side, I'm actually using a block over here, a 90-degree block, so that's getting the head up in the right orientation, but then you got to level it this way. And so it looks like we got it. We're sitting over here on this side pretty close to zero, and then when we spin it around you can't see the gauge, but it's still pretty close to zero, so we're all right. We're off a couple thousandths maybe, but that should be good enough to put a hole in there. So now at least we're set up so we can get ready to re-drill this hole. All right, so now we got it all set up and squared. So now what we need to do is find the center of that hole right there. We're set up with the center tool. And there we go. Now we're centered up. So let's lock the table down. And we are ready to re-drill a hole. So I'm going to come in here and drill this hole out. What I want to do is drill it out so I can tap it with a 7/16 20, because that's about the biggest I can get in there. And still allow me to get that little clip that holds the cam in there. So let's get set up. We got to go to a certain depth, and so I'm just going to touch down, then I'm going to go down. Deepest I can go is like 0.9, so 9/10 of an inch, but I don't want to go that far. I want to go somewhere in the neighborhood around 0.75, so we can see if we can get it deep enough and still have access to our hole. So let's fire this thing up and see if we can drill us a hole. So now what I want to do is come in there with a tap, and I'm going to tap that hole. All right, so now we got our hole drilled out and tapped, and so we are ready to do one more thing before we take this off. We're going to have to machine a hole in our little cover because we got to be able to get our compression release out of it. So we'll get set up on that, and we'll be back here in just a little bit. All right, so we got our cover on now. So what we're going to do is set up in the same spot. We're going to come down and poke a hole in the side of this cover. There we go. So we're drilling right into this. So this is actually going to get removed. We got a long ways we can go to get down there, so no big deal. We'll just keep on drilling, and hopefully we'll be able to break that out of there. So we got most of that drilled down in there. Pull that off. All right, so we are set up with our 5/8 end mill, and so now we're just going to come down and clean that hole out, and we should be getting pretty close to finishing this. So now we have a hole that matches up with our hole right here. So all right, now we just got to blow all these shavings out. And we got the hole tapped, we got the hole cut through our cover, and so then we should be able to make our little transition piece and then put our compression release on the outside, and we should be in pretty good shape. Well, all right, let's get set up over here on the lathe next after we blow all this out and see about making our transition piece. All right, so we got our modified heads mounted on our test motor, and on my little lathe I got my transitions made. And so what that's going to do is this end's going to go into that 7/16 20 hole that I drilled, and I got that cut off, and it'll seat up against the drilling, and it's threaded, and then we got a couple flats on it to lock it down, and then there's a hole in it, and then there's a 10 millimeter for the compression release. So what this is going to do, it actually has to lock down the cam tab, and we got to put a nut on it to get it to lock in. So what I'm going to have to do is I'll put the nut on and then the tab on, run it down in there, bottom this out, and then tighten the nut back to lock the cam down. So let's get set up for that. Let me get this thing spun down on there, and it won't fit quite underneath the gear. I could slip that under, but I think it'll be easier just to take the gear loose. So I've already loosened up the bolt. Yeah. All right, so let's rotate it and see if it clears that nut down there. Maybe we'll be in good shape. Look at there, just clears. You can hear it hissing out of that hole there. All right, so here's our cover with a hole machined in it. So after all that's tightened up, we just want to put a little Vaseline in our rubber seal. Slide our seal on. It's probably going to be tight this first go here. There we go. Now we got a cover on. And now what goes in that hole is that compression release right there. Cover back on here. All right, we'll be back with the other side. All right, so here we are. We got our motor all wired up. So now we get to test out the proof of concept on these compression releases. So here we go. So the compression releases are out. So this would be like without them. And we'll give that a start. Let's get our key on. And when we hit the start, it should crank up. pretty normal. You hear it drag down a little bit, so now I'm just going to pop the compression releases in. And we're going to crank it with them and see if it sounds any better. So much faster. Alright, so let's get a slow-mo video of what the gears look like on the starter with and without the compression release, and just see if it keeps that gear engaged. Alright, so there you have it. A little bit of work, actually a whole lot of work to install compression releases on this Virago, because there's really not a good way to get into the head, so quite a bit of work to get where I could port it. But at the end of the day, looks like it does a whole lot better, and when the battery's weaker, it actually turns over just the same because it doesn't have that initial compression, and it keeps that gear from hopping in and out. So there we go. We'll fire it up one more time just for giggles and see what she do. Starts so fast now I can't get my finger off the button. That worked pretty good right there. Well, alright. Well, thanks for watching.